Welcome to another video for chemistry. In this video, I'm going to be discussing, or I'm going to be working out molar mass conversion questions. So this goes hand in hand with the previous questions or the previous videos, and in this one, we're going to actually apply what we learned in those videos to actual problems in chemistry. Okay? Okay, helium. Helium is a valuable gas used in industry, low temperature research, deep sea diving tanks, and balloons. How many moles of helium atoms are in 6.46 grams of helium? Alright, so this is the strategy that we're going to take in answering this question. First of all, in all of these questions, I want to first find out what my givens are. Okay, what are the given quantities that I have for this question? And for this one, it's 6.46 grams of helium. Secondly, I want to see what are we trying to find? And we're trying to find moles of helium. How many moles of helium are in 6.46 grams of helium? Okay. All right. So the third thing I want to do is I want to get my correct conversion factors, and in this case I'm converting grams into moles, right? Because my given is in grams, and the question is asking me how many moles. So I want to convert 6.46 grams into moles, right? So this is the main idea. So the first thing I want to do, once I have this in place, once I have the general idea in place, I want to find the correct conversion factor. So you can think of a conversion factor as kind of like a transfer ticket on the bus. So if I'm trying to get from point A to point B and there's no direct line, then I want to get the correct transfer that will then transfer me. So there's an in-between step from getting from point A to point B. Okay, there's an in-between step that will correctly get me from here to there. Okay. So what is that step in this case? Well, I want to see first that I have grams, and that's the unit that I want to get rid of. Okay, that's the unit that's going to end up canceling out. So I want that unit to be in the denominator position. Okay, and then in the numerator position, okay, so as you can see here, they'll eventually cancel out mathematically. And in the numerator position, I want the desired unit that I want. And if you go back to the question, it says how many moles. So that's what I want. I want to find out moles and how it relates to grams of helium. So if I look at the periodic table and I look at the chemical symbol for helium, I notice that my mass is 4.03 grams. Okay, and if you recall from our previous video, this piece of information here gives us a lot. This is the atomic mass unit. It's also the molar mass. Molar meaning that's the mass of exactly 1 mole units or 1 mole atoms of helium, right? So that's how many grams per mole of helium. So if I get 1 mole of helium, or 6.02 times 10 to the 23rd power atoms of helium, and I put them together, it will come up to a mass of 4.003 grams, right? And that's grams per mole. That's my molar mass. That is 1 mole of helium. So this is that conversion factor. This plays a key role in this. So again, 1 mole of helium is how many grams? Right? 4.003 grams. So that's my conversion factor. That's the unit, that's the combination of units that I'm going to need to get to my goal, which is mole of helium. Okay, right? So my units of grams will cancel out, giving me moles. All right, so now what's left is just the math. Okay, so this is my basic math problem, which is 6.046 times or divided by 4.03. And that leaves me with 1.61 moles. Okay, and that's it. I've achieved my goal. Now, one thing to consider, and hopefully this makes sense to you, but 1 mole of helium is 4 grams. So it stands to reason that if I look back to my given, I have 6.46. That's just a little bit more than my 4 grams of helium. So then I know that I'm going to have more than 1 mole, right? Because 1 mole is 4 grams, but I actually have 6.5 grams, so I have 1.61 moles. So I have 61% basically of a mole plus my whole mole in 6.46 grams of helium. Okay, I hope I didn't confuse that, but hopefully it does make a little sense. All right, let's move on to our next problem. Let's look at another example. Zinc. Zinc is a silvery metal that is used in making brass with copper and in plating iron to prevent corrosion. how many grams of zinc are in 3.356 moles of zinc? Okay, so I don't even have a full mole, right? I have 0.356 moles of zinc. How many grams are in that? Okay, so again, my strategy, like the one before, I want to find my givens. And this is the unit that I have been given. I've been given moles. And then I want to find out what we're trying to find. And I'm looking for grams of zinc. Okay? So you notice how I have those two important components underlined? Okay, I'm looking for grams and I've been given moles. So my conversion factor is moles to grams. Okay, I want to change 0.356 moles of zinc into grams of zinc. So I need the correct conversion factor. And as you recall from the previous problem, I want to get rid of moles. That's the unit that I want to cancel out, right? And I will cancel out moles to get grams of zinc. That's my goal. So again, I look back at zinc. I look at the molar mass of zinc. So for 1 mole of zinc, I have 65, that'll make 65.39 grams per mole. Okay? If you think back to helium, helium is a much smaller element, right? Okay, it's got an atomic number of 2, whereas zinc has an atomic number of 30, so it's a much bigger element than zinc, okay? 15 times bigger, so naturally the molar mass is going to be bigger as well. Okay, it's kind of like if I were to compare a motorcycle, the mass of a motorcycle compared to the mass of a car, right? The car's mass is going to be much higher. So what if I compared a dozen motorcycles compared to the mass of a dozen cars? The mass is still going to be greater with the car. So likewise here, I'm comparing zinc, which is a much larger element than helium. So the molar mass will be considerably bigger as well. So per mole, I have 65.39 grams. Okay, so 1 mole of zinc equals 65.39 grams. And that's my conversion factor. That's the math that I need to convert to grams. So again, I cancel out my unit of moles in my given. And there's the math. That's all I got to do now. I got to do 0.356 times 65.39, and I end up with 23.29 grams of zinc. Keep in mind again, how many moles of zinc did I have? I had 0.356, so that's about 36% of a full mole. So you notice that 1 mole is 65.39 grams. Well, 35.6% of that is 23.29. So it stands to reason that my final answer, would have much less than my molar mass of zinc. Okay? 23.29 grams of zinc and 0.356 moles of zinc. All right, now let's try one that's a little bit tricky, okay? All right, sulfur is a non-metallic element that is present in coal. So when coal is burned, sulfur is converted to sulfur dioxide and eventually to sulfuric acid, and that gives rise to an acid rain phenomenon. How many atoms are in 16.35 grams of sulfur? So you'll notice that with each of these problems, I'm given a lot of really interesting information about the elements that I'm discussing in the questions, and then towards the end, I'm actually given the information that I need for to solve this problem. So my strategy remains the same. I want to find my givens, and I've been given 16.3 grams of sulfur. And then what am I trying to find? I'm trying to find how many atoms are actually in 16 grams of sulfur. That's a lot. There's going to be a lot of atoms in that. So what are my conversion factors? Well, I want to convert grams, my given, into atoms, right? But here's the thing. It's kind of like my analogy that I was using earlier with the bus. You know, if I want to get from point A to point B and the bus doesn't go directly to there, is there a location, is there a place where I can get a transfer ticket where I can hop onto another bus that will then get me to my other point? So is there a transfer, is there a in-between step? And in this case, there is an in-between step. So there is no direct conversion factor from grams to atoms, but I can convert my grams into moles, which then I can convert into atoms. All right, so let's see how this actually plays out. So again, this is my conversion factor, or my conversion factors. All right, so I want to convert 16.3 grams of sulfur into moles, right? And there's my conversion factor. So if I look at my periodic table, I'm going to see that my molar mass of sulfur is 32.065 grams. So 1 mole of sulfur is 32 grams. And you'll notice that this will allow me to get rid of my unit of grams of sulfur. Okay, it'll allow me to get rid of my grams of sulfur, and then it will then give me the moles of sulfur. So 16.3 grams of sulfur equals 0.508 moles of sulfur. Now I'm that much closer to getting atoms. So now I'm going to use another conversion factor that will then give me atoms. So what would be the conversion factor for atoms? Well, if you recall, just for a second now, 1 mole of anything is how many? Okay, hopefully you've memorized this number by now, but 1 mole of any number, just like 1 dozen of anything, like 1 dozen cookies is how many? 12, right? 1 dozen calculators is 12. 1 dozen cars is 12 cars. Well, 1 mole of cookies is how many? Avogadro's number. 1 mole of calculators is Avogadro's number. 1 mole of anything is Avogadro's number, right? And that is my conversion factor. This is why I needed that extra step, because that extra step allows me to finish the process of converting from grams to moles and then to moles to atoms. So I want to find out how many atoms are in 16.3 grams of sulfur. So going back, this allows me to eliminate that unit, and then my next step allows me to get rid of the moles and gives me atoms. All right, so then here's the math. Now that I know I'm going to end up with atoms, I know my conversion factors are correct, now I can just do the math, right? And this is what the math would look like. Okay, so I do this, I punch this into my calculator, and I end up with 3.06 times 10 to the 23 atoms of sulfur. So that's an enormous amount of atoms that are in 16.3 grams of sulfur. Okay? Well, that does it for our molar mass conversion questions. The next video I will be dealing with a couple of more questions that are a little bit more involved with molar mass. Okay, good luck in your studying.